Hey guys, welcome back to Hustler's algorithm. Today we are gonna be solving this problem, maximum difference between node and ancestor. So you can go through this problem statement, but it simply says that you have to find the absolute difference between two nodes such that the second node will be the ancestor of first node. So let's see what it actually says. So the problem statement is we have to find two nodes, let's say A be the first node and B be the second node, such that the second node will be the ancestor of the first node, and the difference between any two such pair of nodes should be maximum. So the difference between such pairs of A and B should be maximum, right? And this will be the absolute difference. So let's see what is ancestor first. So for one, the ancestor are all the nodes that come in path between the root node and this actual node, right? So the path is like this. So the ancestor for 1 will be 3 and 8. Similarly, the ancestor for 3 will be 8, and the ancestor for 6 will be 8 and 3 because the path is like this, and so on and so forth for all the values. So let's come to our problem again. So what we can do is we can consider any of the path till the root node. Let's say this is one path, this is another path, then this is again one path, and the last part will be this, right? Okay, so now while traversing these paths, we'll keep track of the maximum and minimum values. Let's say the maximum is denoted by plus and the minimum is denoted by minus. So let's calculate this for each of these paths. Start from 8, let's traverse 3. So the maximum, so let's start from 8. So the maximum will be 8 and the minimum will be 8, right? For 8. Now we'll go to 3. Then the maximum will be 8 and the minimum will be 3. Now let's go to 1. We have the minimum as 1. So now, as this is our last node, we'll calculate the difference between the maximum value and the minimum value, and this will be the absolute difference. So it will become 7, right? Now again from here we'll backtrack. So till this point we have the maximum as 8 and the minimum as 3, right? So this one is not there now because we came again from this path. So till this part we have 8 and 3, and the maximum is 8 and the minimum is 3. Now let's go to 6. As 6 will not affect our maximum or minimum values, will not do anything, just traverse any of the paths, that is 4 or 7. Let's go to 4 first. Here this 4 will not affect 8 or 3 because 3 is the minimum and 8 is the maximum. Let's backtrack from here. For 6 we go to 7. This 7 will also not affect our any of the values, neither the minimum nor the maximum. So let's backtrack from here, then again backtrack from here, now again backtrack from here. Now we are considering this subtree, right? So we'll not consider this any of the values in the maximum or minimum. So let's remove 3 from here. Okay, so now till this point we have 8 is the maximum and 8 as the minimum. So from 8 we'll go to 10. Here the maximum will be updated to 10 and the minimum is still 8. So from here let's go to 14. So the maximum will be 14 and the minimum will be still 8. Now we'll go to 13. So it will not affect our maximum or minimum values, but as this is our last node, we'll calculate the difference, which will be 14, which is the maximum value, and 8, which is our minimum value. So the difference will be calculated, which will be 6. So yeah, this will not update our answer because 7 is the maximum value that we can get. So we'll just return 7. So let's see if it is correct or not. Yeah, so we have the output as 7 for this test case. So our logic is correct. So let's code it, right? I'll just write the DFS function which will traverse the node. Okay, so it will be integer DFS, and we have the maximum value and we have the minimum value. Now if our this root is null, then just we can return 0 because this will not give any of the maximum or minimum value. So let's update the maximum and minimum values as the maximum will be the maximum value among the root and the previous max. Similarly for min, so if what we can do is we can write a case like if the root dot left is equal to root dot right, which means that the left value and right value is similar. So it will be the case when it will be the last node because the left value is null and the right value is null as well. So it will become true for the last node, which will be the leaf node. So during this time we'll just return the answer, which is the maximum minus minimum. Else what we will do is we will do the same stuff for the subtrees. So let's write this root dot left, so it will be the left subtree and the maximum value is this and the minimum value is this, and we have again DFS for the right subtree. The maximum value is this, minimum value is this, and we want the maximum among this stuff, right? Because we have to return the maximum value. So we'll just return the maximum value. So yeah, so first our maximum will be the extreme minimum value so that we can update our first value. Like if the maximum value is initially, let's say, negative infinity, so 8 will be greater than negative infinity, so we'll just update max as 8. Similarly for min, we'll just return our DFS function. Let's pass max and min. Okay, let's run it. So yeah, it runs fine. So let's submit it. So yeah, it gets accepted. So thanks for watching. Subscribe to the channel for more such videos. So thank you for now.